But what we want to do is we want to do something like this so that we specify textures to load here. We say that we'd like to load textures slash stone. Now what I'd like to do is I'd like to say textures base. Hold on. So our base texture is stone dot PNM, I think it was. Yeah, PNM. So that we have a base texture, because what we're then gonna do is we're gonna make it so that when we go for our fragment shader, we're gonna use that same name to be the uniform we're looking for, so that we can load multiple textures into various different things. So if you want to have normal maps or specular maps, which of course we want to do down the road, we can do that. So we have a texture, and then we define a shader or shaders, and then we're going to define a fragment shader as being shaders slash fragment or base frag, which is our base fragment shader. And we are going to go for those two things at first. We're going to bind that together because again we need the vertex shader. We could just say that it has to take a model transform and a camera transform and have all of this, because it might be useful to actually have the vertex shader if we're doing stuff like repositioning. Yeah, we're going to specify the vertex shader as well. So the vertex shader will be shaders slash base dot vert. So that way we can pull in the entire shader program here and go for that. So what we're going to do with the camera is simply that we're going to ask the material to get us these attributes out of it. We might even add so that they can be renamed later. But these are going to be handled by the material. We're going to get those out, we're going to set them, and then we're going to go for that. So yeah. So with this done, we can actually load our description file now. Hopefully. We're going to link it, so that should build the entire thing. Takes a little bit longer now that we've got the YAML library in as well. But it works. So what we're going to do is we're going to try and walk this YAML node, and we're going to walk the various different entries in it. And I imagine we're going to start with the shaders, get those in, and then we're going to go for textures as well. So what we'd probably going to start with the textures. That will likely be easier. So what we are going to do in our material is that we want to sort of keep the textures by name. So we're going to go for a standard unordered map. Unordered map from a standard string, which will be the name, and I believe we have a texture class, to a texture, which will be the textures. There we go. Include that as well. Then we'd like to have a couple of various OpenGL types. So over here we are creating our program here, which gives us a GL uint. It wasn't exactly the header I was going for, but what the hell, it gave us the information. So this is going to be our shader program. Then we're going to have we need to import that as well from GLES2 header. Then we're going to have our shader for the vertex, and a shader for our fragment. There we go. We are also going to have to export a couple of locations here, because we need to be able to grab these various wonderful things. Oh, we also have this lot of fun here to deal with, because we also need to actually generate texture elements here as well. We'll get to that in a moment. But what I was looking for was that we need to be able to get the model transform, camera transform, vertex texture coordinates, and actually also the normal coordinates. These are all GL ints, I can see, which was what I was looking for. So we have these, which is going to be called get model transform uniform, or get uniform model transform. We're going to have a get uniform view transform. We are going to have a get attribute vertex position. We're going to have get attribute vertex normal, and get attribute vertex texture. So all of these need to be able to get from our shader program, and then we need to be able to activate it. Great. So what we are going to start by doing is we are going to iterate over our textures. So we're going to have description. We can look up textures here, and with any luck, we might be able to just directly iterate over that for every texture in this. Let's just see if that actually compiles, if it's valid. So we cannot bind to a temporary of type value type. So something like that instead. Because then we're not binding a temporary, we take a copy of it. So we have these. Apparently YAML node is a valid range type. So for every texture, what we want to do is we want to find out what this structure is. Yeah, I probably mean uniform. Apparently somebody's paying more attention to it than I am, which is always wonderful. So we have our textures. We need to get the names of these. So let's see if we can find, there we go. Parsing, building nodes, sequences into maps, converting to from. Because I have no idea. And the amount of documentation here seems to be relatively, limited. Because I'm not looking to output anything, I just want to input. As I said, I'm not paying attention. It's good someone in chat is. Now, looks like we're going to be guessing. So texture dot, yeah, it has no clue what this is. No suggestions for members of unknown. So what we're gonna go into the into the documentation, which consists apparently of the code. So an operator index here returns a node in itself, which is always a good sign. So does it have? It has begin and end, which return iterators. So an iterator is a YAML iterator. A YAML iterator is a detail iterator base over a detail iterator value. So an iterator value is a structure of some type, because who needs to know what it is? it inherits from node and standard pair of node node. Well, so I'm going to assume it has some zombie nodes and other weird stuff. So if it has a key and a value, then this part, the node, is invalid, and then we just have a standard pair. So I guess of a key and a value, and I'm going to assume we have key-value pairs here, because at least to me, this looks like a key-value pair. So the assumption is it's going to be a key-value pair. We'll find out. So with any luck, I should be able to, I want to import that one. I would like to pull out the texture name, which should be texture.first, ideally. We'll try and see if that works. Well, it's linking, so it can't be all bad. We reload this. We get a texture name base. And no spaces or anything like that because I didn't specify any bases or spaces, but we actually get the name, which was what we were hoping for. So that means that we can do an auto name will be texture first as a standard string. Then we're going to grab the file as the second element, because that's what we're specifying. Where did I put? There we go. Specifying the internal name for it, and then the file to load. And then in our wonderful little textures map, we have textures. We would like to place a pair consisting of the name and a texture constructed from file. I suspect that might work. And I need a semicolon. I've been doing too much JavaScript lately. Yep. So that should actually load the texture after that. So if we refresh over here, we get, if we just switch over here, we get our texture name, which is base. We read the magic from it. And I just decided to turn around, get P3. We get skip some stuff. We get an image of 128 by 128 with a max color of 255. So we're actually managing to load that texture in. Now then we also need to grab texture references for OpenGL. We need to do all of this stuff because now we actually have the texture. Just going to transition over here so that Readin doesn't complain about looking at the browser too much. So we got essentially so we've done the equivalent of this step. Now we need to generate the actual texture reference and load the texture data into our wonderful little OpenGL or WebGL instance. So what I was wondering about for a moment ago is, and I've completely forgotten that. We're going to wait with this part of it until later, but we need to grab all of this setup here, which loads the texture. We're going to go over here. Oh yeah, I wanted to look up what InPlace returned, because right now we're getting it to place the texture in it, and it would be, oh dear God, we might be resizing this. That is unfortunate. Yeah, we are going to do a little bit of a change here. We are going to go for, when we place this, we want to grab, where did it go? GLES material H here. Not want that full screen, I just wanted to drag it over here. rather than actual storing the texture, we are going to keep a unique pointer to it. So that's an owning pointer, but we really do not want to copy that around. So we are going to go with that, which means that we can move the texture down here, because then what we are going to do is we are going to go with an auto here. We are going to go for the texture data as a standard make unique texture based on the file that we've been given. So then we are going to make a texture handle here. We're going to add it to generate one for us. We don't need to bind it into texture unit 0 at this point. We'll get to that in a moment. So we're going to bind this texture to texture 2D. That is the texture handle here. Then we are going to get width and height from our texture data. So texture data get width and get height. And the actual data here, we are going to load that in, set up our texture parameters, and then we are going to have another texture handles here, which are going to keep track of our texture. So what I want to do is go over here, create another unordered map. Or maybe rather what we're going to do is we are going to create a tuple here, storing both the glint, which is our handle, and the unique pointer of it, so that we have both of them together and we don't need to look up both or them separately. That means we are going to go for a standard make tuple here of our texture handle and our texture data. And we have no matching function for all to make unique. Okay, so I've been an idiot. That name is overloaded. So this is the class texture. And now we're getting no matching constructor for some interesting tuple leaf. Because I need to standard move this into the tuple so that at this point we release the ownership of this texture data and transfer it into the textures. Look up here. There we go. So that should load the textures. Again, I'm expecting nothing to go wrong, and it didn't. Then we need to load in our shaders. Now, a while back, while we were doing all of this fun stuff, we wrote a small little routine here called read file, which we are now going to move out of this and over into the material, because this is where we need it now. And instantiating a stream, we need to include fstream at this point. There we go. So we can read in a file. And then see, we have these wonderful load shader routines, which I cannot remember if we were kind enough to make global, but we might have been. Otherwise, we're going to be moving them as well, because they shouldn't be part of the render. It should be part of the material. That's not the one, that's the chunk renderer. This is what I need. No, we didn't. So we're pulling this out. and we're moving it to the material. So we have the load shader routine here. And we're also going to take the implementation out here and move that over to the material as well. So DLES material, load shader. Load shader here. So what we should be able to do now is we should be able to say this, or rather just go for it directly. We have our material has a vertex shader, fragment shader, and so on. We are actually just going to grab the code from here because this is what we need. And these have different names now. They are shader vertex, shader fragment, shader vertex, and shader fragment. So load as a vertex shader, not this string, but the description. Looking up the, let's see where it is, shaders, and then it's fragment and vertex. So looking up for shaders and then vertex, and then grab that as a standard string. Great, and same thing down here, just with the fragment shader instead. So we load the fragment shader. Then we need to create our shader program. Oh, dear God, I am mixing camel casing and old style C casing, and I should pick one. So we are just going to quickly go for renaming here. So try and be a little bit consistent, at least with myself. So shader vertex, shader fragment, shader program. So having done all of that, we are going to attach to the shader program our vertex shader and our fragment shader. And then we're going to link that program. And that is wonderful. And then we are just going to we do this little shader compile info output. We are going to want to get program info log, same basic idea. Grab it from this one, length and buffer, just so that if anything goes wrong, we know what's going on, hopefully. So that should link all of that together, print it out. So now we actually have our wonderful little loaded set here. The interesting question is whether we should grab these ahead of time and then just return them, or maybe what we should do instead is sort of cache them. These, by the way, are const. We do not modify our material by getting these. However, we are going to make a little bit of mutable attributes down here, because conceptually we don't change anything, but we are going to cache these so that we don't have to, and I can see I've done it here as well, so that we don't have to look them up every single time that we're going for them. So we're just going to grab all of these names. And have them stored down here. so. And then we are going to initialize these. So when we initialize here, we have initializer list, and all of these are going to be initialized to -1. And what are you? Must be static? No. I have no idea why it's saying that. They should not be static when I'm initializing them on construction. Great. So what we can do now is we can go for like get GLES material, get the attribute vertex normal, and if the attribute vertex normal that we've saved is -1, we need to get it, and then we just return the attribute vertex normal. So to get the attribute vertex normal, we are going to steal a little bit of other code from here, because it is just this little bit of code. So what we're going for is we're going to look for our shader program, and we are going to look for an attribute called vertex normal. And over in our vertex here, we are just going to add one called vertex normal, just so that we don't get linking errors or other weird stuff. And then we're going to assign that to our vertex normal. And then we're going to have basically 5 of these. Get attribute the vertex normal for the vertex position. So this one looks at the vertex position, like so. This is just the one called vertex, and then vertex texture. And we're just going to look at for texture, and we're just going to call this texture. Actually, we're just going to call that normal. And then over in a vertex shader, this is normal, and this is texture, and I need to change that. There we go. So that allows us to grab these attributes. We also need the uniforms. So GLES material, get uniform model transform. Same basic setup. We're going to look at for the uniform model transform. And in this case, it's get uniform location rather than get attribute location, or get attribute location, but that's what they mean. Again, looking at our shader program, we go for the model transform. And then we have our view transform. So uniform view transform, like that, should set us up, or should set up our material, which seems to compile fine at this point. So what we're going to do is we are going to give our, rather than load all of this stuff, which has now been transferred, of course still, okay, at the point where we actually so we're going to activate that, and then we're going to grab the various different things, and that should be fine, because this is the point where we need it. Yeah. So we're going to take this material, and we're just going to move it out for a moment here. So not our chunk renderer, our GLES renderer. It is just for a moment. Instead of having these shaders, it has a material matte, which we will just quickly include here. So we're going to or yeah, we need to well, at this point we do have an OpenGL context, so that's no problem. So we initialize our material on the string stone because we want to load the stone material. We no longer need this, and all of this disappears. And so we have this, we set up our program, then instead of saying GL use program, we go material.activate. And then we don't get our uniform location like that. What we do instead is we ask our material to get the uniform model transform. And then for the view, we go for material.get uniform view transform. So we set those up. And then we have our vertex location. We go for our material get attribute vertex position. And again, material dot get the texture. So we get this set up. Having grabbed those two, apart from the fact that we need to activate, then we're actually good to go.